today. We're going to go a few short minutes. We'll pause it. We'll go over to the hatchery. We'll come back. We'll finish it either as a class like this or at your desks together. We'll see how it goes. But I think the natural question as we look at this is, well, what about the sun? So all of our discussion so far, nothing changes, but we do need to mention the sun's influence on our tides as well, because it certainly plays a role. What about the sun? Now, obviously the moon is a lot closer to us, but it's a lot smaller than the sun simultaneously. So it has this weird little connection. There's an idea in physics known as the inverse square law, which if you guys have done any sort of modeling stuff, you might have heard it. If I say that gravity, and I'm not going to, I mean, you can write it. You do not need to write this down. It's just me talking, so we can talk about the inverse square law. It turns out, as a spoiler for anybody who's in physics, if you want to figure out how strong gravity attracts two different objects, it's this. This is how you find how strongly two objects pull on each other anywhere in the universe. It's that formula. It's that simple. Now, when we talk about the inverse square, here's all that we're talking about and thinking about. Right now, does the mass of the Earth stay pretty much the same? Like, are we losing any mass on our planet just day by day? Not really, because anything that's, like, it's all contained within our atmosphere, right? So even if we burn a bunch of stuff, that gas really does have weight to it. It has mass, and it's just stuck in the atmosphere, but it's still going to the total weight of the Earth. Okay, does the mass of the sun, that's a harder question. Does the mass of the sun change? So it does, but we're going to say no, just to simplify this. Does the distance between us and the sun change? Constantly. Now, all I care about is the inverse square, and it's nice to see this relationship, just why the sun is so weak. If I doubled the distance between these objects, this would, let's say it was 1 before. If I change it to 2, instead of 1 squared, it'd be divided by 2 squared, right? Which is, what's 2 squared? 4. So if I double the distance, I now have 1/4 as strong as gravity. If I triple the distance, it's 1/9 now, because 1 over the square of the radius. Kind of mathy, but does that click okay? That's called the inverse square law. And it turns out gravity obeys that inverse square law. As we look at this, I know that I've mentioned it in class. We're just going to see if you guys can recall. Who pulls harder on the Earth, the sun or the moon? Why? Because it's closer, and you can even say even more specifically because of the inverse square law, and that's how gravity works. It pulls way harder. So as we're looking at this, here we go. Couple things real quick. Sun's gravity. Sun, I'm just going to say sun pulls, and it's through gravity, roughly 50% as strong as the moon. Now, we've seen that the moon is responsible for pulling literally, kind of literally, the oceans up, right? It makes big things, which means the moon's pulling pretty hard. Half of that is still a pretty big influence. Now, as we look at these, turns out there's a couple different situations that we're going to deal with. If, and you don't have to add it to yours, but if we have a sun and it's just kind of hanging out, here it is. Now, if we're looking straight at the Earth, like we're on a single flat plane, so here's the sun and the Earth and the moon. It's not really what it looks like, but we're just going to assume it is. Let's say here's the sun, and then out here's the Earth, and then that looks kind of gray, and here's the moon. In this situation, it looks like the moon and the sun fight over the Earth. Would you agree with that? So I'm getting some glassy eyes. What do I mean by they fight? I'm not literally. They're both pulling opposite directions, right? Now, that's okay with tides, because if I have a high tide here, that makes sense. And a high tide here, it makes sense. We saw that already happens. Nothing weird about this. Now, it could happen in this situation, or it could happen over here and the moon could be there instead, right? In either situation, they're in a straight line with each other. When we get this very specific situation, we get what we refer to as spring tides. Do not be misled when you're talking about the planets and their motion around the sun. This is not the season spring. That is not the same thing. Spring as in like a water springing up from the ground, like a natural spring. So when we define a spring tide, all that this means, and everybody in here is taking geometry, right? All right, I'm going to give almost everybody, most of you, I'm going to do a quick math recall here. I'm just dying to know what collinear means. Anybody recall? What does it mean if co? Like if I'm cooperating with somebody, we're working together or against each other? Okay, so co means together. What is linear? So if I give you 3 points that were together on a line, what might be a really fitting word for this? Collinear, that's correct. So as we look at it, spring tides, they're easy to see. This occur when sun, earth, and moon. Now you could write are collinear, that's the easier way to write it, or we can simply say align in a straight path. Now, if we have this going on, it means that the highs are the highest they're ever going to be and the lows are the lowest they're ever going to be because we see that much more water or earth moving to produce these tides. Spring tides occur in that exactly first picture that we saw. Here is a spring tide, and let's see, yellow, and earth, and moon, but it doesn't have to be necessarily right here. It could be the moon between them, either one of these, and I'm going to say or. Okay, in this situation, we have the highest high tides and the lowest low tides of the whole year. Highest, or the whole month, I'm sorry. Highest high tides and lowest lows. Cool. Spring tides, twice a month, with the understanding that it's not really perfect month because that 24 hours and 50 minutes deal. But twice a month we get the highest tides we can and the lowest tides we can. In contrast with this, here I see the moon and the sun working together to make these tides bigger. And they're called spring tides, like the water literally springing up. Is there a situation where maybe they don't help each other? And I'm going to challenge you guys to do something. You don't have to use colored pencils and stuff. In this picture, the sun and the moon, they both pull the tides the same direction. Show me what it would look like in their alignment if they were fighting each other. Like they're not really fighting each other, and they have bigger tides here. Where else could the moon be that might change the size of the tides? And I want just a quick sketch on your page, and I'll come judge you. So right now, they're on the line, right? Now, the moon rotates around the earth. Is there a situation where they're not gonna, like, spring tides build up bigger tides and low tides because the moon and the sun combine? Exactly. Is there a situation where the moon and the sun maybe try to cancel each other? And if so, what would it cause? I'm confused with your question. Yep. So right now, if you put the moon on either of these places, like if the moon's here and the high tides are big here and here, is there anywhere that the moon could go that the moon and the sun wouldn't stack on? So like their tide, their gravitational pull, wouldn't just make the tides bigger when you combine the two? %. I want to know where's the moon that doesn't make tides bigger.
I just said X because that's like, but it's the Y. It's just like if we're looking at it, if there's on like the or bottom, because you know there was the moon is rotating around the Earth, and the Earth is rotating with you. So then when you're here.
Okay. Quick question, and I promise it relates in. My vocabulary is not fantastic. I'm not super well read, or rather, I'm embarrassingly not well read. In fact, I've never seen this word outside of the science setting. You guys ever heard the word neep? Okay, the word neep means scant, like very little or lacking. So when we see these things, we get spring tides that are big because they're built together. In contrast with that, then, if we want to talk about tides that are lacking or not like particularly great, we could say that they are neap tides. And in fact, neap tides are our next focus. I heard somebody say, and you guys can write that, NEAP. I'm emailing myself a link because somebody I saw tried to describe the movement of everything, and I have a nice simulation that will help us visualize that. Spring tides make everything big. In contrast, everywhere. Oh, good eye. Okay, in contrast with spring tides, we get these neap tides. Cool. Now, in this situation, instead of them being in a line, and this is a weird idea, but what's the opposite of being in a straight line? I like both of those ideas. I heard a curve is the opposite of a straight line. I don't know that. Maybe it's a weird question. I liked what you did, Stonewall. Stonewall did this. This is a straight line, right? This is less straight. Would you guys agree? Yeah. And this is the least straight of all. Cool. Killing it, Stonewall. Neap tides occur in that situation. We're just going to be able to define this pretty easily. Sun, Earth, and Moon form a right angle. Okay, now very specifically, if you guys are interested, we can talk about the phases of the moon at each point because they are specific. However, neap tides, easy to demonstrate the same idea. If we have a sun, which we do, and an earth, which we are, that's not the color they've been using for earth. If we put the moon up here, the moon wants to pull the tides here, the sun wants to pull the tides there. They're fighting each other. They're canceling each other out. This is a neap tide. Now, it can happen at this point in the orbit, right? But alternatively, the moon's going to eventually wind up down here also. So there's twice a month for neap tides as well. Now, it can be really hard to put all these pieces together. It's hard for me to visualize as the Earth spins. And like, if I hadn't done a Lego set that did this and played with it for hours yesterday, I would have a much harder job doing it. Let's take a look at a simulation real quick. But a real quick question just to see if you guys can logic it out. We're going to pause here in just a minute, and then we'll go to the hatchery, then we'll come back and look at the simulation. But I have a question for you. Okay, here's the sun. And I'm not great at three-dimensional space drawings, but are you okay to now it looks like a sphere? Okay, so there's some weird stuff that happens that I just think is super interesting from a physics perspective, but because we're talking about the sun, the earth, and the moon interacting, I think it's relevant. Okay, the earth and all the planets essentially live on a flat plane together. They're off a little bit, but they're all pretty much flat, which I think is just weird that that happens in general. But whatever, I'm fine with it. Let's say we have the earth, and here's the earth equator as well. Now, is this really how the earth equator lives? Why? The earth is super angled, like 24 degrees. It's very angled. Now, beyond that, if this sun, like our star is here and our earth is tilted, if I wanted to draw a path around the earth like this to show where the moon orbits, would it be in line with our equator? Would it be in line with the rest of the planets and everything? Where do you think it is? And do you get the question I'm asking?
You asked where the moon would be?
Yeah. Like when I first think about it, I want to say it's like right there. That's what my gut tells me. How many of you guys have seen a solar eclipse every month or a lunar eclipse every month? So that can't be right behind the earth, right? So where's the moon? If it's not lined up on this flat surface with everything else, weird. Super ethereal, guys. Okay, think about it. I want to know where's the moon. That's it. That's a big question. It's an interesting question, or not. You get 2 minutes to go pack up. Shoes, sweaters, stuff. It's not snowing right this second, but doesn't mean it won't be. Okay, we'll actually give it like 3 minutes. So if you need to go to the bathroom, go quick. So, congratulations, guys. We have one alevin that's been found over there so far. That's pretty exciting. If one's here today, you think we might have more on Thursday when we go back over there? I would imagine so. I sure hope so. Now, the last question, just looking at this, a couple things. You guys looked and hopefully looked about some tidal patterns that show up. Anybody give a thought to why this is the case? Like right now, why is this not a solar eclipse?
Because the moon is tilted and the sun is here.
So kind of. I like.
I was thinking like how it's turning around. Shape of the moon.
So it's not, but that's a good thought. When you're looking at this picture, this is really truly what happens, right? Now the Earth spins around this where it kind of goes through its own thing. It's really tilted, like 25 degrees. It's like if this is 0, 25 degrees like here. It's much more tilted than you might think. Now, within that, turns out the moon does not live on this perfectly flat plane. The moon does not even live on this plane. The moon does its own thing where if this is 23.5 degrees of inclination, this is like 10 degrees and the moon does this. If you ever look at pictures and you see them up north where you see this, like if you ever seen this picture of the sun taken at the same time each day, the sun in the sky makes like an infinity symbol because it looks like it does this because there's so many things that are changing. Our moon, if you do the same thing at the same time every night, you aim up and take a picture of the whole sky so you can see where the moon is, you're going to see a wavy pattern that happens. Now, does the moon actually travel in waves like this? No, but if you have circular motion combined with the spinning of a tilted Earth at a different tilt, then it starts to look like it's waving around as it goes. In reality, I asked why don't we have a eclipse every 2 weeks, a solar and then a lunar on the other side. Turns out we do. We do have eclipses pretty much every 2 weeks, but it's pretty rare that that eclipse happens to land and cast a shadow directly where somebody on the planet is. Like most of our planet's water, and people don't live in the water, so we don't often see them. Okay, going through it. Tomorrow, I'm going to give you guys a couple more minutes right now. Look busy. I'm not going to check if you're actually busy, but look busy. We're going to finish up with some tidal patterns. Diurnal, semidiurnal, and mixed semidiurnal. 3 different specific tides are going to be expected to be able to see. If we look at this, currently, just based on this picture, what phase is the moon in?
Waxing gibbous.
That's a good moon word. I don't think it's right. This is a new moon. Whoever said it over there is good, because notice the part of the moon that's facing our planet is dark. We're not going to be able to see it. Cool.
Is that what you're asking?
What? That's the phase of the moon. It's a new moon. Yeah. Yep. So if you have the moon in the sky, like we don't get the moon a ton here. Let's say the moon was new. Like it's completely dark right now. What side is going to light up first? Is it this side? Is that what the first crescent's going to look like in the night sky? Or is it this side? Cool. We have 2 contrasting opinions. It's not both. It can be both. All right. 3 minutes. I want you guys to be prepared to, if I wanted to start tomorrow asking you about the difference between different tidal patterns, be prepared to answer it. Cool. Page 98. Sweet.